Okay, hello all. Welcome to the channel. And today we are going to study some advanced mathematics courses. So let us start with the question. First of all, we will learn a formula of the PI calculation 1 upon FD x into V. Then this can be written as x minus 1 upon FD f dash D differentiation of f function with respect to D and then 1 upon fd into v. Now we will see its application and solve the question accordingly. So the first question would be d square plus 2d plus 1 times y equals to x cos x. So this question is very important as it comes under RAS pre and SLET Ajmer. So we will done accordingly the question by the previous formula we have learned in the last lecture. So let us start. Firstly, we will solve the auxiliary equation m square plus 2m plus 1 equals to 0. Finding the roots of m, which will give us m equal to minus 1 and minus 1. Now accordingly we can write the CF by the rules we have learnt in the previous lectures. Then CF would be C1 plus C2x e raised to power minus x. So half part of the question is done. We have calculated the CF. Now it's time to calculate the PI. So again PI would be 1 upon FD 1 upon D square plus 2D plus 1 times x cos x. Now this function could be treated as x into v. So here v can be treated as cos x and x separately. Then applying the formula we can solve the PI equation. So let us start. First of all we will write is at x minus 1 upon d square plus 2d plus 1. Now rewriting the cos x as by the previous formula we got 2d plus 2 times 1 upon d square plus 2d plus 1 times cos x. Then x minus 1 upon d plus 1 square 2d plus 2 1 upon minus 1 plus 2d plus 1 into cos x. Now we will differentiate and integrate the cos x as x minus 1 upon d plus 1 square 2d plus 2 times 1 upon minus 1 plus 2d plus 1 times cos x. So this would be treated as half of x sin x minus d minus 1 by d square minus 1 sin x. So then this can be written as half of x sin x minus 1 upon d plus 1 into sin x. So that the final answer would be half of x sin x plus half of cos x minus sin x. Now the complete solution would be CF plus PI. So we will calculate y equals to, so we can write it as y equals to CF plus PI. So then therefore the general solution would be y equal to C1 plus C2x e raised to power minus x plus half of x sin x plus cos x minus sin x. Now we will do another question on the same concept. Question 2. Solve d power 4 plus 2d square plus 1 times y equals to x square times cos x. So again this would be have several many important question here because it has been come under Ajmer B.Sc and Udaipur B.Sc also. So then first of all we will try to solve the auxiliary equation m power 4 plus 2m square plus 1 equals to 0. So this can be written as m square plus 1 whole square equals to 0. So then m equals to plus minus iota and plus minus iota. So here roots are repeated and equal. So the CF would be C1 plus C2x into cos x plus C3 plus C4x into sin x. Now the second part is of calculation of particular integral or PI. Then it would be 1 upon d square plus 1 times x square cos x. Now here there is a twist in the question. We need to calculate it that separately. So we will write cos x as real part, right? Real part of this whole. So we can write it as real part of real part. There are two parts mainly in the e raised to power ix. One is real and second is imaginary. So if real part is e raised to power ix and imaginary part would be e raised to power minus ix. So we will write cos x in terms of real part of the equation. So then this would be 1 upon d square plus 1 x square e raised to power iota x. Then the real part of this whole equation we could solve separately, then we will merge. So the real part is, so the real part of e raised to power iota x 1 upon d plus iota whole square plus 1 m square plus 1 ka whole square, so this x square times. So now then real part of e raised to power iota x 1 upon d square, now opening the whole square, d square plus 2 iota d whole square times x square. Then real part of e raised to power ix 1 upon 2 iota d square 1 upon, now taking 2 iota d common, we can make the term 1 plus d upon 2 iota power minus 2 x square. Then we can simplify it further and we can write it as e raised to power iota x 1 upon 4d square 1 minus, now applying the x power n rule, 1 minus d power d upon iota plus 3d upon 4 iota square and so on of x square. Now we will multiply the bracket with the term x square, then we have minus 1 upon 4 e raised to power iota x ka real part of 1 upon d square, and now multiplying the inner part x square, differentiation of x is 2x by iota, so 2 iota x minus 3 by 2, d square is 0 1, d square of x square is 1 and 3 by 4 iota square is also 1 minus 1, so this would be minus. Then on again simplifying real part of minus 1 upon 4 e raised to power iota x 1 upon d x square plus 2 iota x minus 3 by 2. So then real part can be written as finally we can simplify it and write it as real part of minus 1 upon 4 e raised to power iota x 1 upon d x cube by 3 plus iota x square minus 3 by 2x. So then finally this can be written as minus 1 upon 4 रियल पार्ट ऑफ, किसका रियल पार्ट है ये, अपने को रियल पार्ट निकालना है. सो वी विल राइट फर्स्टली होल द थिंग्स, देन वी कैन टेक आउट द रियल पार्ट फ्रॉम द फाइनल इक्वेशन. सो minus 1 upon 4 या ई पावर आयोटा उसको लिख देंगे cos x प्लस आयोटा sin x और x की पावर 4 बाय 12 प्लस आयोटा ऑफ x क्यूब बाय 3 माइनस 3 बाय 4 एक्स स्क्वायर। और अब इसका जब रियल पार्ट निकालेंगे तो अपने पास क्या बचेगा, माइनस का 1/4 एक्स पावर 4/12 माइनस 3/4 एक्स स्क्वायर टाइम्स कॉस एक्स माइनस एक्स क्यूब बाय 3 साइन एक्स। और अब इसका जब रियल पार्ट देखेंगे तो फाइनली अपने पास आ जाएगा माइनस का 1/48 एक्स पावर 4 माइनस 9x स्क्वायर इंटू कॉस एक्स माइनस 4x³ इंटू साइन एक्स। और ये हो गई अपनी इक्वेशन नंबर 2। अब अपन CF और 1 और 2 को मिला देंगे टू गेट द जनरल सोल्यूशन। सो आवर फाइनल आंसर वुड बी y इक्वल टू c1 प्लस c2x टाइम्स cos x प्लस c3 प्लस c4x इंटू साइन एक्स माइनस 1/48 x4 माइनस 9x स्क्वायर इंटू cos x माइनस 4x³ times sin x. So this would be the final answer. So we have seen a special question where we can calculate the real part of the cos x and then accordingly simplify. Also we can do the another method as well, we have learned in the last lecture, but this is method is quite good. Okay, so now we will similarly one can do the next question I will giving you as a homework. So one can do the next question similarly by the above approach as d square plus 1y equals to x square sin x. So previously it was x square cos x, here it is x square sin x. So same approach can be applied in the below question also, right? Now, so we have completed all the parts of the PI. In the last few lectures, we have seen the different formulas for calculating the PI in the ordinary differential equation of the first order first degree with constant coefficient. And now in this lecture, we have just completed the last part of the solution methods of the particular integral. Now in the coming up lectures, we will be more discussing about the homogeneous linear differential equation with constant coefficient. Thank you.